Okay, welcome back to math class. Today we're going to be talking about symmetry. If a shape has symmetry, that means I can draw a line through a figure in such a way that it would map the figure onto itself. So for example, if I drew a nice pentagon and then I put a line through it right here, then this side would fold exactly onto that side. This line that I drew in the middle is called a line of symmetry, because it's a line that if I folded this over would make it folded exactly onto itself. It would map the figure onto itself. So this is a line of symmetry. This would not be, because if I folded it now this way, this would not match this, because this is a rectangle and this is a triangle. If I folded it there, it wouldn't be mapping the image onto itself. So this only has the one line of symmetry. If it was a weird shape like that, has no lines of symmetry, because there's no place where I could draw an imaginary line that would make it folded in on itself and it would work. You also have things like circles. That's not exactly a circle, but it would have, if it was, it would have lines of symmetry everywhere, right? Because no matter where I folded it in half, it would be perfectly symmetrical. Okay, there are a couple of things we're going to talk about. So this is symmetry where we're reflecting it over a line. You can also have rotational symmetry. Rotational symmetry is where instead of reflecting it over the line onto itself, well, this way, this is not a line of symmetry. Instead of reflecting it over the line onto itself, rotational symmetry means I took the shape and rotated it a certain amount of degrees and it was still the same shape. So for example, if I had a square, imagine this is a perfect square, and I took this shape and rotated it around 90 degrees. It's going to still be the same shape, just tilted 90 degrees. Now if I rotated it 45 degrees, it's not going to be the same shape, because now it's a diamond. It wouldn't be mapped onto itself. So this square doesn't have 45-degree rotational symmetry, but it does have 90-degree rotational symmetry. It also has 180-degree rotational symmetry. If I went one more time, or if I did one more time, it has 270-degree rotation. Then if I rotated it 90 more degrees, we'd be back where we started, right? So you can rotate this square 4 times and it'd still be a square. When we're looking at rotational symmetry, we have 2 ways of describing it: the order of the symmetry and the magnitude of the symmetry. The order is how many times it can rotate on itself. So with our square, that was 4 times, because I could rotate it 4 different times and it still be itself. So our order for this guy was 4. I could rotate it 4 times. The magnitude of the symmetry is the smallest angle that we can rotate it and it still be symmetrical. And the easiest way to find that is to take 360 and divide that by our order, which in this case is 4, which gives us 90, which we know we rotated it 90 degrees each time. And we found out as well that we couldn't do any smaller numbers because when I rotated it less than 90 degrees, it didn't perfectly match anymore. I could have rotated it from the get-go 180, but I would have been skipping one. So our order is how many times we can rotate it, and our magnitude is the total degrees in the square, 360 degrees, divided by 4. Divided by the order. It won't always be 4 depending on what the shape is. But it's 360 degrees, which is a full rotation, divided by how many times we can stop along that rotation, and it still be symmetrical.